Welcome to Fred
and Amy's Math
Math
Shack.
Hi, and welcome to more indices. This is the second lesson on indices at A-level that sort of extends it and looks at some things that go beyond GCSE. First thing to say is I just want to give a fractional powers recap. This is really important. If you have A to the 1 over Q, then that is the same, and you might want to think about this for a minute. What is that the same as? It is the same as finding the qth root of A. For example, if Q is 2 and we have A to the half, it's the square root of A. We could even put a 2 there. We don't normally bother. We just normally leave it by itself. A to the third is then the cube root of A, and so on. So if you then have A to the P over Q, well, what does that mean? Well, there's two ways you can write it. We can use this rule of indices. A to the m to the n is A to the m n. And we can actually go backwards this way and write it as A to the 1 over Q times to the power P, or A to the P all to the 1 over Q. Now generally this one is the more useful one because and I can write that, I should say, it's going to be the qth root of A all to the power P. And that can be really useful because I can, if I want to find a fractional indice, I can basically take the qth root and then raise it to the power P. That's going to be actually quicker than raising it to the power P, which could give quite a big number, and then taking the qth root. Hopefully you're happy with that. Really important, sort of definitions, but they all kind of line up with general. Like if you times the qth root by itself, q times, you'll get back to the original number. That's the definition. And if you times this one by itself, q times, if you use the rules of indices again, you'll get back to A. It's all consistent. So just for a few minutes, I want you to try and write down, like it's a bit of an open question here, write down some fractional powers and what they equal. So this one here is, I could write it as the cube root of 8, and I could square it. Cube root of 8 is 2, so that's going to give me 4. Whereas 27 to the minus 4 over 3. First thing I do is write it as 1 over 27 to the 4 over 3. And then that's going to be 1 over the cube root of 27 to the power 4. Cube root of 27 is 3, so it's 1 over 3 to the power 4, which is the same as 1 over 9 squared, which is 1 over 81. Now I want you to try and write some other ones down, and here's a little guide how you can do it. You can maybe write down some numbers like 2 cubed is equal to 8. Well, what follows from that? It follows that 8 to the power of a third is equal to 2. And then we can build up with 2/3 bits. So if I then square the 8 to the 1/3, we'll get 8 to the 2/3, so that is going to equal 4. And I can make other ones. I could maybe do 8 to the 4 over 3, which means I'm going to raise 2 to the power 4, that's going to be 16. And there's lots that you can come up with. So pause the video, see if you can get some more. Right, okay, obviously I can't, I'd really like to know what you came up with. I found somebody came up with this one once, 2048 to the power of 5 over 11. They basically noticed that 2 to the 11 was 2048, so that means the 11th root of 2048 is going to be 2, and then they would raise it to the power of 5, which is 32. I haven't got my calculator handy, but I'm pretty sure that is correct. And there's loads of other ones. That's the point of this exercise. It's that you'll see lots of possible things that you can do, and it's just trying to get you to have this understanding. Right, as I do this, I'm just going to check that one, and it is indeed correct. And you could put a minus there and it'll become 1 over 32, and it's just making sure you've got that understanding. So, rest of this lesson is going to be loads of examples to try, and it's going to go beyond GCSE ultimately. Now, what I want you to do is try each one, and then I'm going to go through it. So check with me. Don't just watch me do all of them. Give it a go yourself. And if you can't do it, okay, fair enough. Watch me do it. But I want you to really think about them, and we're just going to be building it up bit by bit. So I'm going to go for each one, but I'm hoping you'll pause the video between each one and check your answer. Here it goes, 36 to the half. We talked about this. That's the square root of 36, which is 6. 1/8 to the power of a third. Right, well actually that is going to be the cube root of 1 over 8, which is actually a half. If you didn't know that, I mean, think about a half times a half times a half. Yes, that's 1 over 8. If you didn't think about it, here's another way you could think about it. You can use essentially the fact that it's going to be the cube root of 1 divided by the cube root of 8. And that then gives 1 over 2. Now, where did that come from? This is just a special version of a over b to the n equals a to the n over b to the n. But n here is a third, so I can raise it to the power, and then I can do the cube root. This one here, sort out the minus to start with. It's going to be 1 over 64 to the half, and then we're in a similar position to that first question. It's 1 over 8 because it's the square root of 64. 9 to the 5 over 2. Right, let's take this step by step. It's going to be 9 to the half, all to the power of 5. I'm using that rule I talked about before. Right, 9 to the half is the square root of 9, so it's 3. 3 to the 5. How could you do this in your head? Well, you could do 3 times 3 times 3 times 3 times 3, or you could maybe write it as 3 times 3 to the 4. 3 to the 4, this is a useful one to learn actually. That's the same as 9 squared, because you're doing 3 times 3, and then you're times in by 3 times 3 again. And 9 times 9 is 81, so you can get that quite quickly. And then you can just multiply this quite quickly, so you don't have to necessarily learn that it's 243, but do it bit by bit like that. This one, I see people get caught out by this, so I wonder if you managed it. We add the powers. This is 3 to the power of a half. I know it's quite hard with the indices. Maybe I should have made it a bit smaller. But it's 3 to the power of a half plus 3 over 2. I'm adding them together. Just like we did when it was, say, a 4 and a 7, you get 11. You still add them. In this case, that's going to give me 3 to the power of 4 over 2. I'm running out of space here, which is 3 to the power of 2, or 9. So that's the answer. And I think it's best to combine it, because it's not, not so obvious to see that it's just going to be 9 by looking at it there. 16 to the minus 3/4. Again, sort out the minus. It's going to be 1 over 16 to the 3/4. Right, that is going to be 1 over the 4th root of 16, and then I'm going to cube it. I've raised it to the power of a quarter and then cubed it. I've just changed the power of a quarter to the 4th root more quickly. So it's 1 over 4th root of 16 is 2. You're always expecting to get nice numbers here. Of course, you could raise 15 to the power of 3/4, but you'll get a horrible number. Right, these ones we're doing was basically, I didn't say this, but you should be doing all of this without a calculator, because it's just testing those skills. There are situations where you'll need it in A-level, but also we're just improving our maths, non-calculator maths. 2 1/4 to the minus a half. Okay. 2 1/4. Well, the best way to deal with this, actually, and the only way really, is to write it as a mixed number. So it's actually 9 over 4. That's what 2 1/4 is. 2 times 4 plus 1, that gives you 9 1/4 to the minus a half. What you can do now, in fact, and this is probably the best thing to do, is sort that negative out. It actually turns out that if you do 1 divided by a over b, then, well, you can flip, it becomes 1 times b over a. When you divide by a fraction, you can just swap it round. So this is going to become 4 over 9 to the power of a half. I've dealt with the 1 over 9 over 4. Instead of writing it like that, which is messy, I've actually written it as 4 over 9. And now I can bring that in and square root the 4, square root the 9. We're going to get 2 over 3. Well done if you got that. That one is, I think, is quite a tough one. Be ready to deal with mixed numbers. Okay, 2 more. Right, what about this? I think people get confused by this one as well. Now, first of all, remember that you can multiply in any order numbers like this. So do the 2 times the 3, and then x to the half times x to the minus 5 over 2. It's like the good old days when you simplify things like 2a times 3b. That becomes 6ab because you multiply the numbers and you multiply these. Well, this is just like a harder version of that. So we're still going to get 6. We times the numbers together, and now we deal with the indices. It's going to be x to the half minus 5 over 2, which is going to be minus 4 over 2. Don't try putting roots and stuff in. Actually, the best thing to do is just always try and simplify your fractions before you do anything with them, and that's going to become x to the minus 2, which is much nicer. And you can leave it like that, or you could write it as 6 over x squared. Make sure you can go between these fluently. This is the aim of today, or at least to get you more fluent. Last one, we can actually raise each of these to the power of a half in turn. We've talked about that. We've got that rule that a, b, all to the power n is a to the n, b to the n. So I'm going to get 25 to the half, which is 5. X squared to the half, which is x, because I've times the powers. Y to the minus 4, all to the power of a half. Y to the minus 2. And you can leave it like that, or you can write it as 5x over y squared. So we've dealt with index form and writing it in other ways. How about writing these things in index form? Sort of going the other way now. Bit trickier. Give them a go. First one. Okay, write that root x in index form first. So it's 2x times x to the half. Now don't forget, this x is actually x to the 1, so you can put that in if it helps. And now we're just adding the powers for the 1.5. So it's going to be 2x to the 1.5. That's not particularly nice. Actually, best left is an improper fraction, so 2x to the 3 over 2. So you will again need to go from surds to indices and indices to surds and be able to split it up like this. This one. First of all, sort out the indices actually. It's going to be 6x to the third. And now sort out the fact that you are dividing by it. 6x to the minus third. Basically, if you're going right to left, you would always deal with the negative first. You get it as a fraction. When you go in left to right, actually the negative bit is going to be the last thing you do. Okay, that makes sense, doesn't it? If you go in, because you just go in the opposite way. So get it as your fraction, then put the negative in. I wouldn't do this. Just sounds a really bad idea. If you write 6 cube root of x all to the minus 1, you can do it that way. It just feels like you're going to make a mistake. You're more likely to. So get the indices sorted and then put the minus in front. This third one basically combines ideas of the first and the second, so hopefully you've followed my advice. Sort out the indices first. It's going to be x squared and x to the half. Bring that together before you deal with that 1 minus. It's going to be x to the 2.5, which I can write as a mixed number 5 over 2. And then finally, yep, get it as x to the minus 5 over 2. Well done on your efforts. Keep going. Here goes then. We are delving deeper into A-level territory now, less GCSE. How can we solve equations when I have indices in them? Give these a try. At least try the first one, then see my solution. Well, probably the best thing to do is get rid of that indice and write it as 1 over x squared. That just makes life a bit simpler. And what I would do now, if I was going step by step, I would actually times through by x squared, and then I would divide through by 4. So x squared equals a quarter. You might have gone straight from here to here. Fair play if you did that. But make sure you understand why it works. You can just sort of swap them around. And if I've got that, then I take the square root of a quarter. But don't forget there's plus and minus when you take a square root, because a negative times a negative will give a positive. So actually I'm going to get 2 solutions, plus and minus a half. A lot of times people forget the minus. There are 2 solutions. Here, I would again write it, I get rid of that indice, write it as root x equals 7. Now I'm rooting something, I get 7. So what do I do to get back to x? I'm going to square it, and it's going to be 49. Just one solution here. And finally, x to the 3 over 2 is 8. Let's write it as x to the half cubed equals 8. I can cube root both sides, and I can write it as root x. So root x is going to be the cube root of 8, which is 2. And I've turned it back into one similar to the other one. It's going to be x equals 4. I could actually have done it the other way around. I could have written it as x cubed to the half equals 8, and then I could have squared both sides to give 64 and then taken the cube roots. But then I have to remember that the cube root of 64 is 4. It's easy to take the cube root of 8. So just wanted to talk about that, but this, I'd say, is the better method. Maybe the most complicated one here, maybe not. But what if I say that p is 3 to the power x? How can I write other things in terms of it? Try this out. Right, well, I'll go through the first one. Actually, I'll go through all of them, of course, but I just mean, like, if you're not sure, watch this first little bit. So if I've got 3 to the 3x, I can actually write that as 3 to the x cubed. Remember, when we can times these two together, but we can separate it. Normally at GCSE, you're always going from right to left and bringing it together, but now we have use of going left to right. Because where does that leave us? Well, 3 to the x is p, so it's p cubed. Brilliant. 3 to the x plus 2. I've got an x, but I don't have a plus 2 in there. So basically, we want to get rid of it, and we're going to use another rule of indices, but the opposite way, and write it as 3 to the x times 3 squared. We're adding them together. When we go to the left, so to the right, we can do this. Why does that help? Because it's 3 to the x times 9, which I could write as 9 times 3 to the x, or 9p. Here, I've got 9 to the 2x. How can I link that to 3 to the x? Well, the first thing to do is write 9 as 3 squared. So it's 3 squared to the power of 2x, which is going to be 3 to the 4x. And I've basically turned that into something very much like that first one. I could write it as 3 to the x all to the 4, so it's going to be p to the 4. Let's keep going. 3 to the x over 2. Very similar, actually, to some of the ones I've already done. It's going to be 3 to the x to the half, which is p to the half. I could also write it as root p. 27 to the 0.5x minus 1. Now, there's a few ways you can do this one. My advice is let's get rid of that minus 1 to start with. Let's sort it out rather than changing 27 to 3 cubed. First of all, I'm going to write it as a half x, that 0.5x, and then I'm going to times by 27 to the minus 1. And I've got rid of that bit, so it's going to be easier to deal with. And then essentially I've turned it into something a bit like the last, like some of the other ones anyway. This is going to be 3 cubed to the half x. This is going to be 1 over 27 I'm going to rewrite it as 1 over 27. Sorry, just trying to neaten it a little bit. 1 over 27 times 3 to the 3 over 2x. 1 over 27, and we've done enough of these now. We've done 3 to the 4x and so on, 3 to the x over 2. It's going to be p to the power 3 over 2, because it's 3 to the x all to the power 3 over 2. And this one, this is the trickiest one. All right, what to do first? I think the best thing to do is rewrite it first of all. So it's going to be 9 to the 3x minus 2 all to the power of minus 1. Let's get it off of the bottom of the fraction. That's going to become 9 to the minus 3x plus 2 when I multiply that out. Now, we're in a similar situation to the last one, so I'm going to advise we do 9 to the minus 3x times 9 squared. A bit more to do. And now change the 9 to 3 squared, like we're combining lots of them from before. 3 squared to the minus 3x times 81, because I've done 9 squared, which is going to be 81 times 3 to the minus 6x, which is going to be 81, I'm going to show the full working here, times 3 to the x all to the minus 6, which is 81p to the minus 6, or 81 over p to the 6. Okay, not going to lie, that one took a fair bit. Which leads us to the last sort of questions in this lesson. How do we solve equations where we've got indices like this? Now I'm going to give you a little clue. If I have something like the following, 2 to the x equals 2 to the 7, because this is an equation and I've got 2 as the base of both of them, it must be that x is equal to 7. That's the only possible thing that x could be. And if I changed it and had like an x plus 1 here, it would become x plus 1 equals 7, and x would equal 6. You can see that works. So it's the same idea here. I'm trying to basically get the same base on both sides. First step, actually, I would set them equal to one another. Like equations all have sort of different things you do. Like with quadratics, you always try and set it equal to 0. You don't, when you've got it equal to 0 here, but when you deal with these ones, you're following this different kind of method of solving it. You're trying to get it like this, because then you can set the indices equal to one another. So that's going to become 3 to the x plus 4 equals 3 to the 3. That you've got to recognize that. And now I'm in business. I've got x plus 4 equals 3. I've just equaled the powers or the indices, and that's going to give me x equals minus 1. You can check it if you like. Be 3 to the 3, which is 27, minus 27, which is 0. Okay, next one. Right, they've already got it equal. Where's the common base for 9 and 27? Well, it's going to be 3. So it's going to be 3 squared to the x minus 2 equals 3 to the 3. There's more practice of this on a homework task or like a task I'm going to give you. So if you're sort of not sure, then keep watching through. Maybe go back and try them again afterwards. Okay, because this is not easy, in my opinion. Because it's like a new type of equation that we're solving. We don't solve ones like this in GCSE really. So we then multiply this out. 2x minus 4 equals 3 to 3. And again, now I'm in business. Now I can say that 2x minus 4 is equal to 3. I can add 4 to both sides. So 2x equals 7. And I get that x is going to be 7 over 2. Unlikely to guess that one by looking at it, I think. But we've got there through that solution method. 2 more. Maybe you've just seen this one crop up, okay, but try them. Right, what I would do here is, again, what's the common base? It's going to be 6. So it's 6 to the minus 1, all to the x plus 3 equals 6 squared. You might be getting the hang of it by now. It's the same kind of thing every time. Just get the common base. 6 to the minus x minus 3 equals 6 squared. Set the bases equal. Minus x minus 3 equals 2. So minus x equals 5. X equals minus 5. And the last one. All right, I'm going to show you the answer first. If you got this, minus 5 over 6, then that's fantastic. If not, okay, I'm going to go through it. Right, what's the common base here? Well, we've got 5, we've got 25. It seems to be 5. That 3,125 might be freaking you out a little bit, but we'll get to that. And actually, 125 is 5 cubed, so it's all going to be 5. So it's going to be 5 cubed to the 3x all over 5 to the x plus 4. And that's going to equal 5 squared to the x minus 2. All right, we need to think about this. It's going to be a nice one. It's not going to be like horrible. It's going to be a 5 to the power of an integer is what I mean. So we get 5, 25, 125. We then get 625. And actually, if you times that by 5, you can see, yeah, it's actually just 5 to the power of 5. Okay, simplify this. 5 to the 9x over 5 to the x plus 4 equals 5 to the 2x minus 4 all over 5 to the 5. Now there's two things you could do now. You could like cross multiply and you could get the 5 to the x plus 4 over here timesing and the 5 to the 5 there. That's absolutely fine. Or you can just use your rules of indices for division, which I'm going to do, I think, because I don't need to cross multiply. It's going to be 9x minus 4, because I'm minusing both of them, equals 5 to the 2x minus 4 minus 5. And that is looking much nicer. So that's going to be 5 to the 8x minus 4 equals 5 to the 2x minus 9. And finally, we're able to set the powers equal after all of this, because now I've just got 5 to something equals 5 to something. It took us all those steps because I couldn't just set anything equal until I got to there. 8x minus 4 equals 2x minus 9. Minus 2x on both sides, 6x. Add 4 to both sides, minus 5, which gives us x equals minus 5 over 6, which is what I had there. Whew. All right, that was good. Second lesson on indices, lots of things to think about. Hopefully you've sorted out any, or you've improved any kind of misconceptions. You know, you've eliminated them, you've improved your knowledge. You can now deal with all of these. Keep practicing. It does take practice. There's so many different ways indices and surds can come up. So it's about becoming really confident with it and making sure you understand like the rules and how to apply them. Thanks.